So hello friends, welcome back. This is your friend Prince Goel. As you can see, the topic we'll be discussing now is light, the refraction part first on a popular demand. Let's begin with this topic. So what is refraction? As the definition from book, refraction is the change in path of light when it moves obliquely from one material medium to another. Sounds fine, but what does it actually mean? Let's get into the depth. Okay, as you can see here, we have a diagram. This part being your glass slab, this ray, incident ray here, and this be the refracted ray. The incident ray that was moving along this very path when struck the glass slab at the air and glass interface got deflected towards the normal line. Normal is this perpendicular line. This line is normal. It got deflected towards the normal, and at the other side on the glass air interface it moved away from the normal. Clear? This is how reflection goes. Okay, let's move on to next slide. So you might be thinking, what are the causes? The main cause of refraction of light is that speed of light is different in different media. For instance, in the diagram, when a ray of light moves from air into the glass slab, it slows down because glass is optically denser with respect to air. And at the air glass interface, it moves towards the normal. So when it moved from an optically rarer medium to an optically denser medium, it moved towards the normal. In the second case, when it leaves the glass slab at the glass air interface, the light ray moves away from the normal drawn at that point. The ray of light moves away from the normal. So here in this diagram, this ray here is the incident ray. It should have gone in this along this very path in the absence of this glass slab. But as it came to this very part, this very interface, it struck that part and it moved towards the normal. It moved along the straight line, as you can see by the arrow depicted here, the refracted ray here. This point shows here the refracted ray. Next, when it reaches this very point, it moves along this path, that is your emergent ray. It moves and makes an angle E, that is angle of emergence or the emergent angle, and the distance by which the ray is deviated is known as the lateral displacement. There are two laws of refraction that govern this very thing. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant, also known as Snell's law. This was given by Snell and it was experimentally discovered by this guy. All the three rays, that is the incident ray, normal ray and the emergent ray, all lie in the same plane. This incident ray, normal as marked in the previous case, normal, and the emergent ray all lie in the same plane. So it's quite clear now. Next, let's look at some practical examples of refraction. Refraction can be easily seen by taking a clear glass tumbler as shown in the figure here. Fill it up to the brim or to whatever height you want. Insert a pencil or a pen in it. It will appear to you, if you look from the side, that the pencil or the immersed stick is broken or bent at the point where it touches the water. It can also be seen by doing an activity which I'll be talking shortly after. The next case is refraction of light through a glass prism. This you can see is an equilateral prism here, which has all the three angles that are 60° each. A beam of white light, when passed through it, a part of this white light gets reflected and a major part of it is split into 7 constituent colors given by the combination of Vibgyor: violet, indigo, blue, green, yellow, orange and red. Let's talk about the activity. It's a simple activity that you can perform easily right now. The material required for the activity is white sheet of paper, a pencil or a pen or a marker or a sketch pen, anything would work, and a clear glass tumbler. Okay, what you need to do now, you need to draw two arrows using your sketch pen or a marker facing two different directions. One is in left and another one is in right. Next, what you need to do, fill a glass of water and the same clear glass tumbler that we used before, use it, and what we'll see that when we look the arrows from the glass tumbler, the direction of the arrows gets reversed. This phenomenon is because of the refraction of light. I hope you guys enjoyed this video. Thank you so much. Don't forget to like, share, comment and subscribe. The remaining part of refraction would be covered soon. So, thank you once again.